Action.
Okay. Well, start off, the Earth is 4.6 billion years old, and it's a geoid shape. And it's a geoid in shape because the force of the Earth's rotation forces the magma to bulge out at the equator, and it's this that gives it its rugby ball type shape.
Alright, we're going to start off with the inner core. The inner core is 760 miles or 1,220 kilometers in radius, and it has a temperature of 5,430 Celsius, which is around 5,700 Kelvin. It is a nickel iron alloy, mostly iron I think, and it's a solid due to the immense pressure above it. Despite being such a low high temperature, it is actually solid because it's got all the pressure of all the other layers on top.
Okay. The outer core is 2,266 kilometers thick, or 1,408 miles. It's 4,400 Celsius, or 4,670 Kelvin, so it's a bit cooler than the inner core. And it's a nickel iron semi-fluid mixture, but also has some sulfur in it as well. It's not just purely nickel and iron. It's thought that the rotating of the Earth spins the liquid outer core, and it's this spinning which creates the Earth's magnetic field, which protects us from things like UV rays and solar flares and things from the sun. So it's pretty important.
We're moving gradually outwards. Well, first we'll go through convection currents, which are formed from the inner core because that's where the heat is. So, and convection currents, as you probably know, are sort of like the heat up, it'll go round and then it'll move like that, and that's sort of shape. As it goes up, it'll cool down and come back down. And it's these convection currents which actually move the what are they called? Crust. The plates, the plates on the surface. So we'll go into a bit more detail in a minute, but that's basically.
Okay, yeah, the mantle. The mantle's pretty complicated, really. It's a highly viscous layer between the outer core and the crust, and it's semi-liquid. There's bits of it close to the surface which are more solid, bits more liquid. It's not entirely semi-liquid, liquid or solid. It's a mix of both. It's 2,900 kilometers thick, and consists of 84% of the Earth's volume. So most of the Earth is the mantle. Okay, it's made of oxygen, silicon, magnesium, iron, and aluminium, which this shows as well. And the temperature range is between 500 Celsius and 900 Celsius at the upper part of the crust, and it gets near 4,000 when you get closer to the core. There's two distinct parts of the mantle: lower mantle and upper mantle. The upper mantle is the upper mantle is as well split into two different layers, two different zones. There's the inner asthenosphere, which is 200 kilometers thick, and this is plastic rock. And then the upper part of the upper mantle is the lowermost part of the lithosphere, which is composed of rigid rock. So this is the bit underneath the crusts, and it's actually solid rock. It hasn't quite gone to the plasticky type rock of the asthenosphere yet. And on top of the lithosphere, then you have the crust, which, comparatively speaking, is really, really thin, 5 to 75 kilometers thick. It is literally a very thin crust over the top of the lithosphere.
To go into a bit more detail, it's between 5 and 10 kilometers beneath the oceans. Go through. The crust is 5 and 10 kilometers beneath oceans, and beneath oceans it's known as SEMA. Pretty sure, SEMA, and and that is made up of it's a basalt type of rock, and it's made up of silica and magnesium. Beneath the continental, it's up to 70 kilometers thick, and it's known as Sile. And this is granite rocks made of sort of silica and aluminium. While Sahel is much thicker than oceanic seamer, it's also less dense. So basically, the oceanic will subduct underneath the continental plates when they come together in a convergent destructive Atlantic.
Thank you very much. Right, let's get the next group up.